video, we are going to be talking about oxidation reactions. An oxidation reaction is a reaction through which a bond is formed between carbon and a more electronegative atom. Carbon has an electronegativity of 2.5. Oxidation reactions are called oxidation reactions because this more electronegative atom is typically oxygen, which has an electronegativity of 3.5. The opposite of this reaction is called a reduction reaction. In this reaction, carbon forms a bond with a less electronegative atom, which is typically hydrogen. Hydrogen has an electronegativity of 2.1. In the second semester of organic chemistry, we learn about oxidation of alcohols. In these reactions, a primary or secondary alcohol is oxidized to form either a ketone, aldehyde, or carboxylic acid. This reaction is important for both lab and biological processes. For example, many sugars are ketones, and carboxylic acids are an important component in proteins. And acetone is an important solvent in lab work. The overall reaction is as follows. In the original molecule on the left, it is possible that both R groups are alkane groups, or that one R group is an alkane group and the other R group is a hydrogen. Depending on whether the R groups are alkane or hydrogen groups determines whether the alcohol is a primary or secondary alcohol. A primary alcohol will either be converted into an aldehyde or carboxylic acid depending on which reagents are used in the reaction. A secondary alcohol will always be converted into a ketone. There are several different methods that can be used to oxidize an alcohol. One of these methods is called the Jones oxidation reaction. This reaction will convert a primary alcohol to a carboxylic acid and will convert a secondary alcohol to a ketone. So I drew this example of this primary alcohol, and this is a primary alcohol because the center carbon is only attached to one other carbon. So the Jones oxidation reaction uses chromium salts as one of their reagents. Chromium salts are carcinogenic, so this reaction is not considered a green reaction. Chromium salts are also not soluble in any organic compound, so an aqueous acid must be used as the solvent for the reaction. Due to the presence of water in this reaction, the primary alcohol will be converted into a carboxylic acid rather than an aldehyde. So that's one downside of this reaction. You can't stop at the aldehyde. A secondary alcohol will always be converted into a ketone despite the presence of water. So I'm using this example of a secondary alcohol. And this is a secondary alcohol because the center carbon is attached to two other carbons. And using this alcohol in a Jones oxidation reaction will produce the following ketone. So as you can see, the Jones oxidation reaction has a couple of cons. You can't stop at the aldehyde, and you have to use the carcinogenic chromium salt. One other oxidation reaction that can be used is the Des-Martin oxidation reaction, and this reaction overcomes both of those cons. This reaction uses a reagent called Des-Martin periodinane, and it has the following structure. So now I'm going to show the reaction mechanism of the Des-Martin oxidation reaction. So as my reagents, I'm going to use the Des-Martin periodinane, and I'm going to use the following primary alcohol. The oxygen that is part of the primary alcohol has a partial negative charge because the oxygen is more electronegative than the carbon atom it is attached to. So it's going to pull the electrons towards itself. And the iodine that is part of the Des-Martin periodinane has a partial positive charge. Because of this, the oxygen is going to attack the iodine. And this is going to cause one of the acetate groups to serve as a leaving group. This step produces the following intermediate. This oxygen now has a formal positive charge. The acetate group that served as a leaving group now has a formal negative charge. And this acetate group is going to be used to deprotonate the oxygen with a formal positive charge. This step produces the following intermediate. In this next step of the reaction, a molecule called triethylamine, which has the following formula, is going to be used to attack this hydrogen that is attached to this carbon. This is going to cause the electrons that form the bond between the hydrogen and the carbon to flip up and form a pi bond between the carbon and the oxygen. This formation of the new bond is going to cause this entire group to act as a leaving group, and the bond between the oxygen and the iodine is broken. This step produces the following final products. As you can see, the products of this reaction include an aldehyde rather than a carboxylic acid, like the Jones oxidation reaction. If we were to use a secondary alcohol, the products would include a ketone. So now that we've drawn out the entire mechanism, I'm going to show a way to figure out what the final products of the reaction will be without needing to draw out the entire mechanism. So I'm going to show this example with the following secondary alcohol. So as previously stated, the Dust-Martin oxidation reaction always produces a ketone. So we know that the final product will be some form of ketone. So in this reaction, we know that the molecule will always lose one of the attached hydrogens, as well as the hydrogen attached to the oxygen. As well as these two hydrogens being lost, a double bond will form between the carbon and the oxygen. So now we are left with this carbon that has a double bond to the oxygen, as well as the two attached R groups, resulting in the following ketone. I'm going to use another molecule as an example. So this primary alcohol is going to lose one of the attached hydrogens, as well as the hydrogen attached to the oxygen. And a double bond is going to form between the carbon and the oxygen, resulting in the following aldehyde. This has been an explanation of oxidations of alcohols with a focus on the mechanism of Dust-Martin oxidation. Thanks for watching.